So, hello and welcome to Lesson 7 of our Java series. Today we're going to go over interfaces and more inheritance, but mostly just interfaces. And as always, if you have questions about the class, you can join us on Discord, which you can see the link on the screen. There you go. So let's dive right in. So today is actually going to be a little bit more practice today. There's not a whole lot of new material to cover, but we'll go over what are interfaces and what is the final keyword, which is a little unrelated, but still useful to know. And then we'll go over some real world examples and we'll do some practice with interfaces and just object-oriented programming in general. This is where you're going to start kind of building more, I'm going to say realistic, but maybe not quite, but semi-realistic applications. Questions about what we're covering today before we start? Cool. All right, let's do it then. So what are interfaces? From an understanding standpoint, you can think of interfaces as behaviors. They define the behavior that certain classes should have. The way that they define these behaviors is by specifying method signatures. So interfaces only have method signatures. Just to review, method signatures are a method's name, its output, and its inputs. Okay. Interfaces cannot have variables, and they don't have the implementation of the method, only the name, inputs, and outputs. And then, after defining an interface, classes can implement that interface. Implement is a keyword here, and it's actually what you type when you're coding. And what it means is that if you have some class that implements an interface, that class must have methods built out from the interface's method signatures. So let's say I have an interface called addable, right? It is capable of adding. I'm defining the behavior of adding things. Let me get my... Oh, that's right. I forgot how to draw on here. Oh, well. If I have an addable interface, I can say, okay, the interface has a method called add. It outputs an integer, and it takes in 2 integers as input. And then if I make another class like my math class, and I say it implements the addable interface, that means that my math class has to define an add method with an integer as an output and 2 integers as inputs. Basically, an interface just guarantees that the classes that implement it do stuff. And I'll go over that a little bit more in a minute. You okay, Yuhi? Okay. So additionally, classes can implement multiple interfaces, right? So let's say I have an addable interface, and let's say I have a subtractable interface. And then I can have my math class. If it implements both the addable interface and the subtractable interface, I have to have methods from both. So if the addable interface defines an add method, and the subtractable interface defines a subtract method, then my math class has to have the add method and the subtract method. And lastly, interfaces can inherit from each other. So you can have a multipliable, a multiply interface inherit from your add interface, and then that multiply interface also has to have the add method. And we'll cover all this. May be a little bit confusing now, but we'll cover examples in a minute. But based on what I've just described, do you have questions yet, or are you okay? Okay. So we're going to move forward. So here's kind of a basic example. I've defined an interface called drivable. And if we were to read this in kind of plain English, we would say that we have an interface drivable where any class that is drivable can start and it can drive. So in kind of plain English, we're describing the behaviors that these types of objects can have, that drivable types of objects can have. And so, where's my pointer? There we go. We have this, the input lag. Oh, so any class that implements this drivable interface must have a start method that returns a Boolean and a drive method that takes in an integer and returns nothing. So you can see here, we have a car class that implements our drivable interface. And so we must define the start method, the Boolean start. You look here, it's the same method signature. And then if you look here, we have our drive method, and again, the same method signature. So in English, we would say that the car class fulfills the drivable interface by defining these methods. Another way to think about interfaces is like contracts, and that's why the word fulfill is used, because the interface guarantees that the classes will have certain methods, right? That's like a contract that you're setting. My phone buzzed. Where is it? Sorry, I just need to make sure it's not someone trying to get into the class. Please give me a moment. And no, it's coronavirus notification, I believe. Oh, I see. Nope, it's a message. Okay, if you need help, please let me know. Right, so another way to think about interfaces is kind of like a contract. You're guaranteeing certain behaviors. And that's why we say car fulfills the drivable interface by defining the start method and the drive method. This is just kind of vocabulary that I'm teaching you here. This is how people will describe things when talking about interfaces. Any questions so far? Cool. All right, going forward. This is just telling you what I just told you. A car fulfills a drivable interface by implementing the start and drive methods. And like I said, they can be thought of as contracts. They guarantee certain behaviors exist. Another, and possibly the most important thing about interfaces, or really the reason why interfaces exist, is polymorphism. We learned about polymorphism in last class, but we'll review it briefly. It says that if I have some hierarchy of classes, right? So I have like a child class and a parent class and like a grandparent class and anything lower in the hierarchy can be treated as something higher in the hierarchy. Because if it's lower, it has everything that the parents have, right? It inherits all of that. The same is true of interfaces. So that's why you need the full method signature. Because if I try to use a car object as a drivable, it has to have those start and drive methods. So if you're comfortable with polymorphism already, this shouldn't really be anything new. In your thinking of parent classes, child classes, or superclasses, subclasses, you just include interfaces in that mode of thinking. But if you're not yet quite comfortable with polymorphism, this might be a little more difficult to understand. Do you have any questions about this so far? Cool. All right. Then this is going way smoother than I anticipated. So yeah, if there's anything questionable, please tell me. Otherwise, this class is going to end up being really short. All right, so other things about interfaces, they cannot be instantiated. I don't know how much we've talked about the word instantiated. To instantiate is to create the object from the class. To create an instance, like an actual object based on the class. You cannot do this with interfaces. You cannot create an object from an interface. So I can't do new drivable. That doesn't work. If you want to use an interface, you have to define a class that implements the interface, and then you create an object from that class. Now, if you want to guarantee, did I not? Right, okay. And earlier, I mentioned that interfaces don't have variables, right? But you can still kind of encourage that an implementing class will have variables. If you remember getters and setters, this is kind of the way to do it. So if an interface has like a, if we go back with the car example, get number of wheels, right? And set number of wheels, that implies that there should probably be a variable on the class number of wheels, right? And at the very least, the interface guarantees that the implementing objects can get and set the number of wheels, however they might do that. Maybe they don't necessarily store it in a single integer variable. Maybe they do it in a different way, but the important part is that the behavior is defined. And so with polymorphism, with kind of guaranteeing these behaviors and these contracts and sort of things, interfaces become very important in Java. If you're doing testing, often you want, if you're testing your code, which you should be, and but we're not going to cover that until the I guess intermediate Java series. When you're doing testing, you want to not use real versions of some code. Sometimes you want to mock them, create a fake version, because maybe you're testing one thing, but the one thing uses another thing. But you're not testing the other thing. You just need to be able to use it. So you create a fake version of it to use with the part that you're testing. And we call this mocking. So interfaces, by using an interface, you can create a mock version of the class that implements the interface. And in that way, you can just use polymorphism to swap them in and out. Or if, for example, let's say you are, here's a good example. Let's say you're building a delivery service, right? Let's say you're like, or let's say you're aggregating all the delivery services, right? So you can place orders with like Yogyo, Betalminju, Shuttle, all these kinds of delivery services. You just want, if you were writing code to do this, you wouldn't want to have to like do all sorts of crazy logic to pick the correct delivery service, and have like a different variable for each delivery service, because as there's more and more delivery services, that gets to be a very long list, and that's not fun, right? Because you'd have to write all that code, and we don't want to type too much. We're lazy. So what you would instead do is you would have a delivery service interface, right? And then you'd have and then that interface might have like get price or send delivery or get delivery area or these kinds of things that define how a delivery service behaves. And then you would have like a Bedelminju class implementing that interface, and then you could store that in your service. And then you can swap between them as you need because they all have the same behavior, right? So this allows you a lot of flexibility because let's say a new delivery service pops up like Weguk Delivery or something like that, right? You just have it implement the interface, create a new class that implements the interface, add it into your code, you're done. It's way easier than having to go through and add new code everywhere to support the new thing. If it follows the same behavior, just implement the interface and you're done. Does that make sense? I know I kind of went off on a tangent there. Okay, cool. And if for folks who are watching later, when we do practice, that tangent is going to make a little bit more sense. I think we'll actually use that as one of our practice problems. So that's any questions about interface overall before we go forward? Cool. All right, so now for the second part, what is final? Final is just another keyword, much like public or void or for or whatever. And final can be applied to classes, variables, and methods. What it basically means is that it cannot be changed. So for example, if we have a final class, we can't create a subclass from it, right? Because then through polymorphism, you're kind of changing the class, right? So final prevents that. On methods, it prevents overriding a method. If you do a subclass of some other class, and one of the parent class's methods is final, the subclass can't override it. It has to use the parent version of the method. So that's what final will do there. And then on variables, when you're in a class, you can mark a variable as final, and then you have to set that variable in your constructor, and then you cannot assign a new value to that variable. Sorry, I'm adjusting my mic because I'm realizing I'm peaking. So basically that means like once you start with the value, you're going to keep it. You're not going to change it. There's kind of little strange workarounds around that, but we'll maybe talk about that later if it becomes necessary. But I think usually you won't have to worry too much about that. Any questions about final before we move forward? Cool. Final is not used very often. It's just one of those things where you won't see it really often, but it's really important to know because when you do see it, you really need to know what it means. But it's also not a very large thing. So that's pretty much it for final. So let's dive into real world examples. So we're actually going to use some of the classes that we used from our previous lesson. And this is actually part of the Java JDK. I assembled, I guess, this graphic. Oh, we have another person joining. Hello, welcome. Hello. Oh, you're on your brother's computer. Okay, cool. Don't forget to mute, please. Cool, thank you. Right, so I made this graphic straight off of the Java API reference. So this is, if you did the homework, you've already been using this basically. So in Java, all classes inherit from object automatically. You just don't write that explicitly. But this is kind of a description of how the hash map, which we learned about last class, how it gets assembled based on the interfaces and classes that are in Java. And this is very, very common. This is a very common style of doing things. Yeah. You can't see it? What the hell? Okay, let me restart it. So, were you able to see the screen previously? How about now? Better? Can you see the screen now? No? Still no? You still can't see it? Shit. That's a problem because I think I did everything right. Shit. Let me just try again, I guess. Also, Yuhi, similar to muting your microphone, you can also turn off your camera if that's easier for you. All right, your entire screen. Screen 1. Share. Can you see now, Catherine? This is a problem. What if I do this? Now can you see? Crap. Is it a problem on your end? Did you accidentally click my name and then it's focusing on me rather than the presentation? Yep. Yeah. On the, I don't know if this is different for you and me, but in the main window, not in the side panel, you should be able to click on the people, or if you mouse over, there's a little pen icon. There's a pin icon, like a thumbtack. Do you have that clicked on me or no? Because if you do, that would block the presentation. Okay, cool. Oh, okay, so you can see the screen now? Oh, okay, cool. I was about to be like, crap, if that's not it, I don't know how to fix this. Yeah, no worries. Okay, so what we have here is a pretty common way of assembling classes using interfaces and normal class inheritance. So as I mentioned before, all classes inherently inherit, from the object class. Everything in Java is an object. And then we have a map interface, right? Which, so again, remember, we're focusing on a hash map. So this is how we assemble a hash map. A map interface says we have this get method, this put method, this clear method, this isEmpty method, mo. We have all these different methods. And then this abstract map class, ignore the abstract part for now. We're going to learn that next lesson. This abstract map implements this map interface and has method definitions for all of these methods that the interface defines. So then the hash map class inherits from abstract map and therefore also implements this map interface. Because if the parent implements the interface, then the child also implements the interface. So the hash map also has the get, put, clear, isEmpty methods. And then the serializer interface, it's only a marker interface, which we're not really going to cover because generally you don't need to use it. And this clonable interface, which only has this one clone method. The hash map implements these in addition to implementing the map interface. So it has all of these put together. And so you can use a hash map as a map, like we did in last week's lesson. You can use a hash map as a clonable, as a serializable, as an abstract map. Again, polymorphism, just like we talked about last week. Does that make sense? Do you have any questions? Okay, if I'm going too fast, let me know. Okay, so let's get a little more complicated. Last week we also talked about Arraylist, and the same thing that we did for hash map, we're going to do for Arraylist here. It's just a little bit more complicated. So we have our base object just like before, and then we have our collection interface and our iterable interface. Now, collections guarantee that you can add to the collection, clear all the entries from the collection, check the size of the collection, and remove items from the collection, right? That's the collection behaviors. And then an iterable has behaviors like for each. You can loop through all the values of an iterable. It has an iterator method, which you can use to go through each item. It has a splitterator method, which I actually don't know and wanted to look into, but I ran out of time. And so this abstract collection implements these interfaces, right? So this abstract collection has all of these different methods that these interfaces define. Again, just like we talked about before. Additionally, this list interface also implements, or not implements, this list interface, actually have a bug here, extends those other interfaces. Pointer. So the list interface also requires that these methods exist. However, it also defines extra methods like sublist. Okay, so just like class inheritance, interface inheritance gets all the stuff that its parent interfaces has, but it can add its own stuff too, like sublist. So then this abstract list class also implements this list interface. And then lastly, for our array list, we inherit from abstract list, meaning we have all this stuff up here on the top 2/3 of the slide. And then in addition to that, we implement the random access interface, which again is just a marker, and the clonable interface, similar to the hash map. And so we have all of these methods put together. Any questions about that? Cool. Now at this point, you might be wondering, why do we do all this stuff just for an array list? Why don't we just make an array list? Because an array list is not the only thing that we're building. So if we look at this example, this is runnable future, which is a lot of crazy concurrent programming, multi-threading stuff. We're not going to cover this in detail because this is like advanced level stuff. But it's a good example of having an interface that branches in multiple directions, right? So in our array list example, everything's kind of coalescing down to this array list class here, but that's just because of how I wrote it. There's many other interfaces and classes that implement this collection interface. There's many other interfaces and classes that implement this iterable interface. I just didn't show them here. But this slide is showing a different perspective. So we're focusing on the interface and seeing how things branch out into it and how it branches out into other things. So our runnable future interface inherits from two other interfaces, runnable and future. Who would have guessed? So a runnable guarantees that anything that's runnable has a run method, which is a very descriptive name. And then a future interface defines that things can be canceled, you can get from them, and you can check if they're done. So is the future complete, basically, which is kind of a funny thought. So this runnable future interface guarantees that all of these parent interfaces methods are implemented by any class that implements this interface. So it just kind of combines the two, right? So that's kind of our baseline. And from there, we can have more interfaces if we wanted. For example, this is a runnable future. We can have a runnable scheduled future, which has all, again, like normal inheritance, it has all of the things that a runnable future has, but it also has its own stuff in addition to it, like is periodic, like a schedule. You can have recurring events on a schedule, right? And then, in addition to interfaces, we can implement this interface in our classes. So we can have a future task, which will have all of the methods that runnable future has. And we can have a swing worker, which again has all the methods that the interface has, plus a couple of more. Okay, so that kind of shows the flexibility of interfaces. Any questions about that so far? Cool. Any questions about everything we've covered so far? Because now we're going to dive into coding ourselves. All right. So next up, we are going to practice. So open up IntelliJ if you have not already. And let me know when you have IntelliJ open, because I know it does take a second to open. Okay, great. So we're going to create a new project. Eventually. There we go. And as usual, you're going to click Java up here at the top if it's not already selected. And you're not going to pick anything else. You're just going to do next. You're going to skip create project from template. And we're going to give our project name. You can call it whatever you want, but I'm going to call it 06 underscore interfaces and inheritance. Again, you can call it whatever you want, whatever makes sense to you. And then click finish. All right, are you with me? Cool. And as usual, we're going to expand our whoop, I cannot click. Okay, as usual, we're going to expand our project tab on the top left. It read my mind. That's cool. I didn't actually click. And we're going to expand this, and we're going to start with our source. Create a new package. Why is my computer being slow? Create a right-click new, do package. I'm going to call it org.codeseoul.java. Let's call it interfaces. Let's go with that. And let's create our main class. So after that, right-click, new class. I'm going to say main. And you should end up with your project looking like this. You have your package over here on the left with the main class underneath. And at the end, public static void main string args. Come on, autocomplete, please. There we go. Whoa. Let's try that again. There we go. All right, so let me know when you're up to this point. Okay, great. Now I had to remember what the hell the example was that I was. What was I talking about before when we were talking about? Yeah, we'll just stick with the one that I was thinking of previously. Actually, no. Let's take a look back, maybe, because I think the example I was coming up with was better. Nope, can't remember. Okay. So let's create a new. So right-click your package, go to new, and select Java class. But here, we're instead going to select interface instead of class. And we're going to. And I really wish I could remember that example I thought of earlier because I was really happy with it. But I've since forgotten. Okay. Let's create a new interface called drivable. Okay. And go ahead and hit enter. And you should get something that looks like this. Cool. And then, whoops. And then you'll notice here on the left side, it has the I instead of the C to show that it is an interface and not a class. And just like we did in our example in the presentation, let's create a new method called start that'll take in nothing. Oh, I guess we don't need the public. Is that right? Cool, that works. And we'll create another method called drive. I want to keep to my example here, so let me find it real quick. Distance. So far, so good. Okay, great. So this says that any object that is drivable can start and can drive, and then has these inputs and outputs as we've defined. What is it complaining about here? What do we got? Yes, I know it's never used. We're getting there. So now let's create another interface. We're gonna get fancy here. Actually, no, let's just do another class. We'll do the interface afterwards. Create a new class called car. All right, and I'm gonna split this view here so you can see both. And let's have let's just keep it simple. Let's go ahead and implement these start and drive interfaces. So we can just do up here we can do public class car implements drivable. And you'll notice now that I've said it implements drivable, IntelliJ is complaining that, hey, you're implementing this interface, but you haven't actually created the methods that the interface defines. So again, remember, it's like a contract. It guarantees that these things happen. If we don't create these methods within a car, Java won't let us compile. It'll be like, no, this is invalid code. You can't do this. So again, on Mac, I think it's Option Enter. On Windows, you want to do Alt Enter. On Mac, it might be Command, but I'm pretty sure it's Option. That'll bring up your context menu here, and you can just say Implement Methods. And it'll ask you which methods you want to implement. We want to do all of them, so just say OK. And it does it for us. Apparently, we need this override thing. I didn't know that, but yeah. So writes code for us. We don't have to do all that. And then let's make system.out.println. Let's just make this print I'm starting. And then for drive, oh crap, you know what? I messed up. Actually, no, I didn't. I'm going to use this as a good example. We'll go with that. So let me know when you got this typed out. Nice, you're fast. Okay. And then on our start method, let's actually have it return true for now. So that's a good start. We have a car. It's drivable. We can do stuff. Now let's go back to our main class briefly. And let's go ahead and let's get a car going. But instead of doing a car directly, just like we did kind of last week with polymorphism, let's do drivable. Let's call it drivable vehicle. Vehicle, I can type, I swear, is a new car. Now in this case, we're not defining a constructor because we're not going to do anything in the constructor. The car is not storing any data right now, and that's okay. And then let's go ahead and start our vehicle, and then let's drive our vehicle. Let's drive it 15 because we're driving 15 qubits. I don't know. Who needs units? in reality, we'd want to say something like distance in meters or distance in kilometers or whatever, but for this example, we're okay. So let me know when you got that typed out. Nice. And then let's go ahead and run our main method. So nice little shortcut here is you can just click this arrow and click run main, and that just does everything for us. Eventually. My machine's running a little slow today, I'm not sure why. So there you go, it says I'm starting and I'm driving, just like our methods say. So far so good. Any questions about this before we get into, this is kind of basic interface things. What are you, I know, we're getting there. Any questions about what we have here so far? Cool. So this is a super, super basic example. It's also terribly boring and not interesting or useful. So let's make this a little more interesting. So a couple things. There are different, slight tangent actually. There are different coding conventions around interfaces. Many people firmly believe that an interface should always start with capital letter I. And I would say that these people are more common than not. I don't particularly ascribe to this. I think it's not a bad idea, but I don't think it's 100% necessary. However, because it can cause a lot of trouble with people if they follow this and you don't, it's probably better to get in the habit of it. So let's start that habit now. So go ahead and in your drivable interface, or you could do it here too, it doesn't matter. Wherever you see drivable, right click it or command click it if you're on Mac without a mouse. And go to refactor and rename. And let's call it I drivable. And then just hit enter. And the nice thing about IntelliJ is that everywhere that drivable is referenced, it'll find that code and rename it for you. So you don't have to find every single file where drivable is mentioned. You can just do it there and it changes it for you. Because doing it yourself by hand is prone to mistakes, but IntelliJ will not make that mistake. So do you have the interface renamed? Okay, great. Thank you. So let's get interesting. Let's add another interface. So again, on the project pane, right-click your package, go to New Java Class, and let's do iFuelable. And again, select Interface, and then Enter. So for our fuelable interface, let's add a thing that is fuelable. We should be able to see how much fuel there is, so we should have a get fuel method. And we should also have an add fuel method. Oh, I just realized something that is not in the curriculum that you really need to know. Crap. Okay, we'll see how much longer this takes, and if there's extra time, I'll just add it now. But first this. And add fuel should take in some integer fuel amount. Is there anything else you can think of that something that is fuelable would need to, a behavior that it would need to have? Okay. Um, I'm debating whether or not to add a spend fuel. Because theoretically that should be used internally. But because it would be used internally means that we don't necessarily need to define it as part of the public interface, the public contract. So let's just leave it out for now. So now let's, so we have our fuelable. Let's make our car, a car also uses fuel, so it should be fuelable. So let's modify our car. Or do you have the stuff from iFuelable written out already, or do you need more time? Okay, cool. So in our car class, let's also make it implement iFuelable. And again, it's going to complain because we haven't implemented those interfaces. So because we hate typing, we can do Alt Enter or Option Enter and say implement methods. It'll ask us which ones we want to do. We want to do all of them, so just hit OK. Oh, oops. All right, so your car class should look more like this. Do you have this? Okay, great. So you'll notice here, get fuel, add fuel. Now, add fuel isn't necessarily a setter, but these are similar to getters and setters, right? So it implies that a car should track its fuel. So let's go ahead and do that. At the top of our car class, actually, here's a thing. Fun little trivia. You can tell if someone learned programming in America or in Europe because Americans tend to define their variables at the top of classes. Europeans tend, again, this is not 100%, this is just common. Europeans tend to define their variables at the bottom of the class. The order doesn't actually matter, it's just a matter of preference. But we're going to do the American style because. So let's do private int fuel amount. And so we'll add this variable here. Or if you want to be fancy and European, you can add it at the bottom. It doesn't really matter. And let's go ahead and add a constructor. Not cat, car. But we're not going to have it take anything, but we're going to set the original fuel amount to 0. Now, technically, it's going to do that already because the default value for an integer is 0. However, rather than expect every Java engineer to remember that, I find it better to just explicitly set it to 0. That way no one has to go like, wait, is this a problem? Like, no, it's not, but I don't want to make people confused. So we'll just explicitly set it to 0. Because actually, you know what? When you buy a car, it does already have gas in it, doesn't it? Oh, no, you know what? We're going to do this for now. And then if we have time to go over the extra thing that I want to add to the curriculum, that's when we'll mess with this. But for now, this is good. So after you've created the fuel amount property of the class and created a constructor where we set the initial value for fuel amount to 0, let's go down to our new methods, and in get fuel, we should return fuel amount. And for add fuel, we should do fuel amount plus equals the input fuel amount. So far, so good? Okay. If you need me to show you a different part, please tell me. Okay, cool, great. That's funny. All right, so now having it be fuelable and drivable, but having no relationship between driving and fuel is kind of silly, right? So let's go ahead and this is actually going to work really nicely for the new curriculum if we end up adding it. When we let's actually add another variable. Let's do private int let's call it fuel rate per distance. And let's actually have that as an input to our car. Yeah. I cannot type. Okay, so go ahead and add something like this. Let me know when you have that. Okay, great. Now in our drive method, what we're going to do is let's create a new variable called fuel consumed, and let's set it to the distance times the fuel rate per distance. And then following that, let's take our fuel amount and reduce it by the fuel consumed. What is it complaining about here? Oh, let's actually do this too. And let me, sorry, give me a second. Make this a little easier for you to see here. Oh, okay, 1 second, sorry. There we go. All right, so let me know when you got that typed out. Cool. And then one thing here, if you go ahead and scroll up, you'll notice here IntelliJ is really helpful. And it tells us fuel rate per distance may be final. Because we've only set this value in the constructor and we haven't changed the value, it's suggesting we make it final, which actually makes some sense. A car's fuel rate, its mileage, should be constant. In actual reality, it's actually not, depending on like your tire pressure, the engine efficiency, the oil you use, all these kinds of things, like they can change the fuel rate. However, we are simplifying everything. So let's go ahead and make fuel rate final. Okay. And then IntelliJ will stop complaining. There's this one related problem. Don't worry about it yet. We're going to get there. And then after you've added final to the fuel rate per distance, let's go ahead and let's modify our drive statement here. And let's say I drove unknown units distance using fuel consumed. Whoops. Fuel. And I'm just kind of doing this here so you can read it. I have fuel amount remaining. Okay, so let me know when you have this typed out. This is just kind of a description of what's happening here. You can hear me breathing, can't you? Fix that. Let me know when you've got that. Okay, great. So now if you scroll back to the top, you'll see this one related problem. We changed our constructor, or rather we added a constructor in the first place. So what we need to do is back in our main class, we need to tell our we need to give the parameter to our constructor, the fuel rate per distance. So I don't know. Let's make the fuel rate 2. This is a magical car with magical fuel efficiency. And then before we start the car, let's do vehicle. Typing is hard. Dot add fuel. Huh? Huh? Oh, ha ha ha. So here's a problem. Drivable is not fuelable, right? So what we can do now is this is where you kind of get into application design, because as you're developing things, you'll come across these kinds of problems. Like this kind of thing where you're like, oh, I have this interface, it does this. Oh, I needed to add this new behavior. Oh crap, now everything is broken. We have ways to handle this. So what we can do, actually, let me see if IntelliJ will do this. I don't know if it's smart enough to do this, but we're going to try. Okay, well, nah. What we're going to do is in our package. So right now we have iDrivable, right? But again, drivable is not fuelable. It doesn't have things like add fuel, get fuel, these kinds of things. But we don't necessarily want to use car directly, because then if we want to use a different kind of vehicle, we're stuck, right? We have to go back and rewrite our code. And you want to avoid those things. You want to avoid rewriting code whenever you can. Or if you are going to rewrite code, keep it as small as possible, and keep it as kind of like the background work rather than the main like in your face work. Like the main function is the kind of main in your face work, and you want to avoid rewriting that as much as you can. So what we're going to do, we're going to define a new interface that is both drivable and fuelable. So let's go ahead and in our package, right click, new Java class, and let's call this an iVehicle and select interface. Okay. Oh, you know what? I actually forget the syntax for this. Give me a second. Right, how do I write it? Okay, I don't remember what the syntax for this is, because, oh, there we go. Cool, found it. Yeah, so we can have iVehicle extends iDrivable and iFuelable. And then we're done with that. And then we just have car implements iVehicle. Okay. So let me know when you have these changes made. Okay. And then lastly, let's go back to our main class, and instead of iDrivable, make this an iVehicle. And now that it's an iVehicle, we have access to this add a fuel method. So let's add, I don't know, 60 fuel. And let me know when you've got that. Cool. So now we should be able to run this again. Eventually. And you'll see, oh, I missed a space somewhere. You'll see it says I drove 15 distance using 30 fuel. I have 30 fuel remaining. Because we started it with 60 fuel. It uses 2 fuel per distance, and we had it drive 15 distance. So that's cool. We have this really complicated system just to make a car drive, right? Like having 3 interfaces for one class, that seems like a giant pain in the ass, right? Yeah. But let me show you where this gets kind of cool. Let's close our car for now. And let's add a new class. Let's call it generator. Now stuff's gonna click. Oh, I wish this class was in person, because either now or soon you're gonna be like, oh, and I wish I could see the expression on your face. But this is where stuff gets cool. So create a new generator class. And our generator class can implement iFuelable. And then just as before, do either option click or option enter or alt enter and implement methods. It's going to ask us which ones. We say all of them, and we're good. So now, you okay? Oh, okay. 괜찮아요? 아, 죄송해요. Okay. So do you have this written out, Catherine? Okay. Can you kind of guess where we're going with this, or not quite yet? Okay. So our generator. Let's go ahead and create a constructor for it. So public generator. Actually, no, I'm sorry. We don't need to add a constructor. We're not going to do anything like that. But because it's fuelable, because we have these methods that manipulate fuel, like a car, we should probably track the fuel. So private int fuel amount, just like we did before. And then get fuel should return fuel amount. Whoops, this dot fuel amount. You technically don't need this, but I just like to add it. And then this dot fuel amount plus equals the input fuel amount. Now, you might be thinking, hey, this is the same code we wrote for car. There are ways to avoid needing to duplicate code, but we're going to learn that next week. So I'm just going to ask you to be patient on that part. But let me know when you have this written. Cool. So now, in this way, oh, actually, you know what? I wonder, does IntelliJ have a feature like that? I thought I've seen a feature like this before. Looks like maybe not. Oh, it does. Huh? Dude. Well, that sucks. Okay, never mind. Sorry. So now you'll notice. So not you'll notice. So we made our generator implement iFuelable, right? So now this iFuelable interface. We're able to kind of branch out and use anything that's fuelable, right? A generator doesn't really have much in common with a car except that it also uses fuel, right? So in this way, we're getting a lot more flexibility. So then let's say, I'm not actually going to type all this out, but let's say that, let's say you're doing some sort of simulation, or maybe you're doing a game or something, where you have a whole bunch of fuelable objects and you went and bought some gas and you want to go put fuel in all of them, right? You can just have a collection of your fuelable objects. And in this way, even if they're not otherwise related, like a car and a generator, again, don't have much in common except that they both use fuel. In this way, you can use them together. You know what? Let's just write it. Screw it. So let's do. Let's go ahead and in our main class, let's create a list of iFuelables, and I don't know, what would we call this? Bleh. I don't know. Let's just call it fuelables. Screw it. Fuelables. Yep. And then let's make this a new array list. And yeah. All right. And then after that, oops. Let's go ahead and add our car to our fuelables. And then after that, let's create our generator. And also add that. And let's go ahead and move these out, move them down here. And let's do cool. Sorry, I know I'm doing a lot here, but it's just faster and easier to. Cool. So go ahead and make your. Is this not a real word? Whatever. Roll with it. Go ahead and update your main class to look like this. And once you got it typed out, I'll kind of explain what we're doing here. Let me know if you have troubles with what's going on here. Okay. Sorry, maybe that was a bit too much too quick. you want to share your screen? Don't worry, I'm not going to put it on this other screen so that people won't see your name. Maybe I need to stop presenting for you to. So on the bottom right, there should be a Present Now button. There we go. All right, what do you got? Ah, right. I'm sorry. Okay, so if you put your cursor on list, the first red, yep, click there, and then do, you're on Mac, right? So Option Enter. Yep. And then over there, do Option Enter again. There you go. Yeah, sorry about that. Yeah, I kind of breezed through importing. So when I wrote this, I did the Option Enter thing and added these imports. Oh, right. I'm not sharing my screen. I'm going to take back presentation real quick. Okay. Well, come on. Okay, so yeah, I added these at the top here. Sorry, I didn't show that in the full version. So to explain what's happening here is I created a list to track all of our fuelable objects. And then we create our car and we add it to our list of fuelables. We create our generator, we add it to our list of fuelables. Then we loop through each fuelable in our list and then add 60 fuel to each of them. Then we start our car, drive our car, and then we just check how much fuel the generator has by doing get fuel. So if we run this, you'll see I drove 15 distance using 30 fuel. I have 30 fuel remaining, just like before. Generator has 60 fuel. So in this way, we can treat our fuelable objects as fuelable objects regardless of what their subtype is, because we've guaranteed that all of them can add fuel, for example. Okay. And we could do a similar thing with drivable. For example, you can drive a bicycle. I don't know if you'd call it driving, you call it riding, but you could drive a bicycle, but it doesn't use fuel, right? So you could have a bicycle implement drivable, and then you could treat a car and a bicycle as the same thing, right? So in this way, we can have interesting combinations of objects and make things flexible. Does this kind of make sense, or is it still kind of like, what, why? Okay, cool. So we have 30 minutes left. How ambitious are you feeling? Okay. There is something really important that I failed to add to the curriculum. So I'm going to try it now, if that's okay. All right. I'm going to update the presentation as we do it. Okay, let's try this. Okay. So, you've heard of errors before. You've probably seen them when you've tried to compile your code. But errors and exceptions are actually a really useful part of programming. And a good programmer will create exceptions, will create errors, because they can actually help you make sure your application works properly. Or in cases where it doesn't work properly, it can help explain to you why it doesn't and how you can fix it. So the way we do this is through exceptions. So exceptions define exceptional behavior. That is the application behaving in an undesired or unexpected way. Presentation on the fly. So there are some basic runtime exceptions. Runtime exceptions occur when your application is running. Most exceptions will be of this type. There are also compilation exceptions, and you'll see these when you try to compile your code. Compilations protect you from compilation exceptions protect you from making mistakes, and runtime exceptions often let you know you have a bug. So this is why they're useful. So like most things in Java, exceptions are just another type of object class. Exceptions can interrupt the program flow. So when, for example, when you hit an error, your application will stop running, right? And often you want that because the application is in a bad state and you don't want it to continue. Exceptions. So you can instantiate exceptions like any other object, but they won't interrupt your program execution until you throw them. For example, if come on, snap, there we go. Sorry for doing this on the fly. Cool. If we do something like runtime exception my error equals new runtime exception, something bad happened, and then we throw my error, this will stop the execution of the program and show the error. Yeah. Okay. Does that make sense so far? Okay. Some common examples. Let's say you are you can use exceptions to help pinpoint or prevent bad behavior. For example, using our fuel rate thing, what if we set our fuel rate to 0? Wait, no, crap, that's a bad example, isn't it? Hold up. We're doing multiplication, not division. But let's say we were trying to calculate how much fuel we needed. We would divide by the fuel rate, right? But if we set our fuel rate to 0, then we would be dividing by 0, which you cannot do. So in the case like that, you may want to throw an exception like, hey, fuel rate must not be 0. Often, exceptions can be used to prevent bad values from being set, like 0 for something that must exist, 0 or negative numbers for something that must exist. Or if a string must be a certain length, you can use exceptions to explain to the user that the given string was incorrect, right? Things like that. So does that make sense now? Cool. So that's cool, but when you do an exception, it interrupts the program flow, right? But what if you want to record that an exception happened, but you don't want your program to crash? That's where try catch happens. The try catch blocks allow you to capture and handle errors when they happen without making your program crash. This is really hard. So you use try to identify the lines of code that can produce some error. You use catch to identify and handle the error, to identify, not some error, some exception, to identify the exception and write code to respond to an exception happening. This is actually try catch finally. Try catch else finally, I think. Not 100% sure. We're going to find out because I'm getting my languages confused. But I think Java has try catch else finally. I might be getting it a little bit confused with Python, but we're going to find out. You can use else. Again, I need to confirm this. This could be wrong. In the event that an exception does not happen, though technically that's not necessary, but and you can use finally to run code whether an exception happens or not. And let's do a quick example. How am I doing on time? Oh boy, okay. Quick example. I should really make a pre-made format for that. If we have this is going to be a really crappy example, but we'll run with it. Hold up. Actually, let me check on that else thing. Java try catch else finally. Oh yeah, Java doesn't have else, does it? Yeah, that's a Python thing. Oops, sorry. Java doesn't have else. My mistake. Sorry about that. Probably should have checked that before I started talking about it. Sorry. This is why you don't do things on the fly. So catch runtime exception E. Oops. Let's also double space this. Beautiful. Throw new runtime exception. It broke. And then this will never be executed. And then system.out.println E. Finally, this will run whether or not an exception happened. Oh, please don't be too long. It's gonna be too long. Ah, it hurts. Okay. Yeah. Okay. So this is kind of what all of it together looks like. So we write a try block for code that we think could throw an exception. In this case, we're going to explicitly throw an exception, just to kind of demonstrate. And then because the exception interrupts program execution, this line won't run. Once this exception gets thrown, it's going to jump immediately into the catch block. And then this code will execute, which is just going to print out the exception. And then following that, the finally will run whether we hit the exception or not. So if we weren't throwing this new exception, this would still run. Let me double check that because I want to make sure I'm not getting confused. Yeah, no, that's good. Any questions about this? Okay. So try says that the code in this block could throw an error. And if this code does throw an error, that will trigger this catch block. In the case that the runtime exception, in the case that the exception is a runtime exception, you can actually have multiple catches. So think of this as kind of like, I'm going to try to do this, and then I'm going to catch myself if I make a mistake. Otherwise, I don't need to catch, and I'm just going to continue onward. If this block of code here does not throw an exception, this won't execute. Does that make more sense? Okay. So with the time we have left, let's actually incorporate that into our code here. Real quick, let's create a new class. And let's call it out of fuel exception. Okay. And we're going to have this extend runtime exception. Let me know when you're to this point. Cool. Now, there's all sorts of fancy stuff we can do with exceptions, but often this is enough. So we're going to go, I'm going to move this to the bottom real quick. What we can do here is we can do something like if in our car's drive function, before we print out the driving bit, we can check if this .fuel amount is less than 0, right? In that case, we ran out of gas, right? We ran out of fuel. So we should probably throw a out of fuel exception. Right? Because you can't drive if you don't have fuel, right? So that's an unexpected behavior. That's something that the application doesn't want to allow. So we can kind of use an exception to kind of enforce the rules of our application. So let me know when you got that typed out and tell me if that makes sense to you. Okay, cool. So now, let's go back to our main. And at the end here, let's try to drive with our vehicle. Whoops, what is typing? Let's drive for 100. And I'm going to close our out of fuel exception for now. So just add this one line down here. And once you've got that, let's go ahead and run it. Okay, do you see something similar to what I have here? Yep. So that's this is actually ideal. This is the kind of thing we would want to happen in a real world application. Well, not quite, but it's on the right path. However, what we probably really want to do is, if we run out of fuel, we probably want to respond in some manner, right? So, actually, you know what? I'm sorry. I wrote a bug. Let's go back to our car class. This condition here, let's actually move it up here. And let's not a fuel amount is less than 0. We don't want to change the fuel amount. We want to, if fuel consumed is greater than fuel amount, do out of fuel exception. Yeah. So let me know when you have this changed. Sorry about that. Should have done that right the first time. My mistake. Okay, cool. So let's go back to our main now. And let's do try. And let's put our vehicle driving inside this try, and let's catch our out of fuel exception. Oh wait, you know what? Maybe we should have left it as is. Nah, no. This is fine. I think. I don't know. Whatever. We'll figure it out. And then in our catch, let's go ahead and say, hey, if we ran out of fuel, let's say we're stopping for gas. And let's do vehicle.drive, or I'm sorry, vehicle.add fuel. Let's do 500, screw it. And then vehicle.drive, 100. And then finally, let's go ahead and car has the hell? Yeah, something like this. All right, so let me know when you got this typed out, and then we'll talk about it, and then we'll run it. Okay, great. So what we're doing here is we're going to try to drive for 100. But if we run out of fuel, we're going to hit an out of fuel exception. So in that case, we're going to say, hey, let's stop for gas, let's add the fuel, and then let's try driving for 100 again. And in either case, whether we run out of fuel or not, let's print that we have this much fuel remaining. Does that make sense? Cool. So let's try running it. Cool. So you'll see we have all the stuff from previously, but then it says stopping for gas, and then I drove 100 distance using 200 fuel. I have 330 fuel remaining. Car has 330 fuel remaining. Hey? Can I see your code? Oh wow. Okay. Can you share your screen? Let's see what you have. Oh, sorry. I didn't see that you had it shared. Okay. This looks good. Can you go to your car class? Oh, yep, there you go. It should be if fuel consumed is greater than this dot fuel amount. Because this dot fuel amount will never be greater than this dot fuel amount. Line 24, the one highlighted in yellow. So it should be fuel consumed greater than fuel amount. So basically, if we try to consume more fuel than we have, that's a problem. Now, so the left side needs to be, nope, undo. So let me say it in English. So if the fuel consumed is more than the fuel amount, we need to throw the exception. Okay, so fuel consumed is not defined on the class. It's only defined within the scope of this method. So there is no this. Yeah. There you go. And lastly, we don't want to actually change the fuel amount if we would run out of fuel. So go ahead and line 22, move it after the condition. There you go. Perfect. All right, now try it. There you go. Cool. So now let me go back to sharing mine. Resume presenting. Okay, there we go. All right, can you see? Okay, great. So now in our main, let's try changing drive. This one, let's try changing it to 5. 5, numlock, okay. And then let's try running it again. Now you'll notice we had 30 fuel remaining. So driving for 5 distance is no problem, and we don't encounter the exception. And so it just drives like normal. Okay, does that make sense? Cool. So I'm going to change this back to 100 just for demonstration. And that covers, I mean, exceptions can get a little more complicated than that, but at the basic level, that's it. Yeah, do you have oh, another thing I was going to do was so start returns a Boolean. I was going to have it, if there's no fuel, start will return false, like it didn't start. But you can add that later if you want. We already got the point across and we're out of time, so I didn't want to get too deep into that. So today we talked about interfaces. We talked about interfaces inheriting from one another. We talked about how classes can implement interfaces. We went over some real-world examples of interfaces. We also talked a little bit about final, and we did kind of a bit of an example practice, and we also talked about exceptions and error handling, or exception handling. So we got a lot done today. Do you have any questions about what we covered, or? Okay, cool. So I will post this online very shortly. I'll do it immediately after this. And I do, if we go to the presentation, I have not laid out the homework yet. So I'm going to do that now because this weekend's been kind of crazy. I also, because I was not planning on doing exceptions and exception handling, I need to add additional resources for that. But other than that, we're good to go. So yeah, any questions about anything in general, or are you good? Okay. As always, you can ask questions on Discord if your sister's getting tired of you. And because we are here to help, and I'm not the only one on there. We have a whole bunch of experienced people on there who can help you. So, and we also have the additional resources if you need things explained in a different way. So, yeah, no worries. Beyond that, thank you for coming, and thank you for listening and trying, and hope to see you next week we will be covering. Next week we'll be covering abstract and static. And then we will have our final class, building a text game in Java. And we will have. Will you guys be okay to do a class on the 27th, or will you be busy with holiday stuff? Okay, cool. So we'll do a class as normal on the 27th, and we'll do Java's abstract and static. And once that's done, you'll have all the kind of core stuff. And then our final class will be building a text game to demonstrate everything that we've learned. So yeah. All right. Well, thank you for coming, and I will see you guys next week. No worries. All right. Bye-bye.